What's up everyone, Paul the Solar Guy here. I just wanted to take a second to do a deep dive into what I just found to be one of the best features of the Enphase 4th generation battery system. We're currently in front of an Enphase IQ Combiner 6C. We left the plastic on. We're going to let the homeowner be able to peel that off. But inside the Combiner 6C, right on the dead front, it has a nice sticker saying rapid shutdown instructions. There's multiple different ways that you can initiate rapid shutdown with this system. And honestly, I think the rapid shutdown possibilities are the best part of this Enphase 4th generation energy system. As an installer, or if you're an installer listening to this, I know that's going to sound kind of strange. We all have a love-hate relationship with rapid shutdown, but this system makes it absolutely seamless, much easier to install, and much more cost effective. So again, inside here on this rapid shutdown instruction sticker, it says to initiate rapid shutdown, we can turn off the PV aggregate breaker, which is this breaker here. That would be applicable if this unit was installed outside and readily accessible 24/7 and the utility allowed it. This unit, as you can see, is inside, and in our area the utility requires a knife blade disconnect or a visibly open, visibly closed disconnect that can be initiated just with a throw of the hand. So continuing it on, it says you can turn off the aggregate breaker, or if using a grid side or PV side disconnect as an RSD device, ensure it is turned off. So that's what we're using. We're using a PV disconnect, and that gets wired in between the feeds coming from the DER bus into the PVA breaker. So we just intercept those feeds. We're going to open that up and show you in just a second here. But what I think is probably most phenomenal, and which I just found out, is if we continue down on this rapid shutdown instructions, it says the system is in rapid shutdown mode with PV batteries generating touch safe voltage while maintaining its internal functioning. So I actually was on the phone with tech support. I was like, what is touch safe voltage? And he was like, you know, I don't really even know. Touch safe voltage, that's a new term for me. So what we're gonna do is we're gonna test that out right now for you on camera. We just had our final electrical inspection. So right now the system is up and running. If I show you in live status in the monitoring system, so you can see that's the live status of this system right now. You can see exactly where the power's going, where the power's going to, from, everything like that. So functionally we are making solar power, we are charging the batteries, and we are putting power into the home and putting power into the grid. So as I mentioned, we have a disconnect wired in series with this PVA breaker. I'm going to open up this dead front, show you some of the wiring, and then we're going to initiate that disconnect and start taking some tests. So now we have the dead front open on the Combiner 6C, and we're going to take some measurements real quick. So if I click on my multimeter there, if I check the solar breaker, this is where the solar's feeding into the DER bus. We're getting 247.8 volts. If I check the battery breaker, we're getting 247.2 volts. And then if I check the PV aggregate breaker, we're getting 247 volts. So we're getting 247 across all of our DER breakers. Again, this is where the solar feeds in from. In this particular installation, we have a detached building, but this is where the solar feeds from the solar panels. This is where the battery feeds into this bus bar, but these are separated. So this side of this bus bar actually comes back into these lugs to feed that breaker. But what we've done is we've intercepted those wires. So we spliced them on here, ran them out in red to a disconnect, and then back on black to feed that breaker there. So there's an outdoor disconnect located in between these wires and this PVA breaker. So now what we're going to do with everything running is we're going to go outside and we're going to shut off that breaker. So that would be if a first responder, firefighter, anybody with an emergency personnel had to come up and shut off power to the building, they can shut off that disconnect and know that the solar and the battery is shut off in addition to power from the building. So let's go shut off that disconnect now. So this is the rapid shutdown switch for the solar and battery system. This is located right next to the existing electrical meter, so it's very easy for first responders to find. It's also right on the other side of the wall of our equipment, so it's centrally located as well. But in an emergency, this would be the first location that first responders, firefighters, and any other emergency personnel would show up to disconnect power from the building. So a super easy disconnect to find, easy to know if it's open or closed or if it's on or off. So again, we're going to initiate a rapid shutdown of this energy system by shutting off this outside disconnect. And so now back inside at our combiner 6C, we just shut off the outside disconnect. We're going to test again all of our breakers on our DER bus. And also too, if we look at the batteries, which we have located over here, you can see the batteries are all initiating red LEDs. So indicating that they're shut down or there's an issue and they are not producing. So again, back at the combiner 6C, we're going to run tests on these voltages again. So we'll start with the solar again. We'll just do the same pattern we did. Solar, we have 0 volts. If we go over to the battery, testing across the phases, it's actually bouncing between 10 and 114 volts. Come get a shot of this. So that is the voltage on the battery breaker going back and forth between touch safe voltage, so that way it can still function and monitor the system. And then if we go into the PV aggregate breaker and test that voltage again, same voltage, 10 to 114, when we were measuring 247 volts constant. And just to prove functionality of this system, again, we are still on grid power. We only initiated the rapid shutdown. So if we check our primary source backfeed lugs, again, still that constant 246, because we're still on normal grid and utility power. If this system was in off-grid mode, or if the grid went down, we would not have voltage on those backfeed lugs, and none of the rest of the panel, none of the rest of the electrical in the house would have any power, and the microgrid would be off because the rapid shutdown disconnect is off. So the rapid shutdown disconnect outside, whether it be a PVA breaker, a PV disconnect breaker, if this PV aggregate breaker loses voltage, it shuts down everything on the DER bus. And you know what? We don't have an electric vehicle charger installed on this installation, but I can see the terminals for that, so I'm going to check that voltage as well, just to see if the electric vehicle charger would also be down. And yes, that is the electric vehicle bus bouncing between that same 10 to 100 volts. So everything on the DER bus gets shut down. So again, the rapid shutdown on the Enphase 4th generation battery system is fantastic. As part of the combiner 6C, it's super convenient. It's much easier to install, much more cost effective, and it's much more intuitive, because we have one disconnect that shuts off everything. That's the way it's supposed to be. We don't want a disconnect for the solar and a disconnect for the battery and running around. If it's an emergency, you want to make it easy for those first responders, and to just have one disconnect that shuts everything off is very convenient. And the other nice thing is we can wire into this breaker so that disconnect can be a 60 amp rated disconnect that shuts off 60 amps of solar and 80 amps of battery, or we could even have another 80 amp breaker there, so we could have up to 160 amps of battery. So if you have 160 amps of power and you need a disconnect for that, you're going to be using a 200 amp breaker or a 200 amp disconnect, and if we have to install that outside on the building, it's going to be this massive disconnect, and the homeowner is going to think it's ugly. Not only that, but we're going to need a massive pipe to go out to that disconnect with bigger wires to be able to handle that ampacity. Whereas with this solution, we can intercept that PVA breaker that's sized basically only for the solar output. And by shutting that disconnect off, it signals everything else to shut off, regardless of whether it's on grid or off grid. So again, super intuitive. Energy management systems have come a long way. They're listed now, they're legal. And the more people that know about these features, the better installations will be across the board and the better grid services for everybody, because we all use electricity. So the more clean electricity we can have and the easier we can make the installations and the more cost effective the prices can come down, then it makes it more accessible to everybody. So again, that's going to do it for this video of the IQ Combiner 6C and the Rapid Shutdown potential installations. We're going to have a much more in-depth video coming soon of this whole installation, of the process of mounting the batteries to the wall, pulling the wires between them, running all of the commissioning. So if that's something that you're interested in, make sure to like this video, subscribe to the channel, stay up to date for more. Again, I'm Paul the Solar Guy. Thanks for staying tuned. Stay sunny.